Okay, so this is from 14.1, the notes, and I'm just going to go through one of each of the trig functions and graph them and talk about the steps I go through. Hopefully this will help you. Also keep in mind this explanation that I'm giving to you is the type of explanation you would give to someone else as part of your quarter project that you'll get on Tuesday. So first thing, I have number 9 is a sine function, and with sine and cosine functions I need two pieces of information. I first need to find the period and the amplitude. Okay, the amplitude is always equal to any multipliers of the sine function. If you look at this equation, I'm looking right here to see if there's some multiplier or how many sine functions are there. There is only one. If I put a coefficient here, it would be 1. So the amplitude is 1. That means that the function will go as high as 1 and as low as -1. Next, I need to find the period. The period is always, for sine and cosine, 2 pi divided by, we call it b, and b is the multiplier of x. Right here I see pi x. That's how many x's I have. So this is 2 pi over pi. The pi's cancel, and my period is 2. So I can go over 4 hash marks, 2, 3, 4, and put a 2. Obviously halfway would be at 1. And then I'm going to come out 1, 2, 3, 4 to -2 and -1. Now I need to go in and actually produce the sine wave. I know that the sine function starts at 0, it goes up to its maximum, back to 0, down to its negative, its minimum, and then back up to 0. And so this is my sine wave. Again, just like little children, we don't give sharp objects to them. We don't create sharp, pointy sine waves. You guys can see already I've not got a perfect drawing, but it's pretty good. And I'll put a little arrow on this end, a little arrow on that end, and there's my sine wave. It has an amplitude of 1, that's how high it is, and it's got a period of 2, that's how long one rotation takes. And so there's my graph. So in describing this, I talk about how I found the amplitude, how I found the period, and how I used those to create the curve. Number 18 is a cosine function. Well, I still need the same two pieces of information. The amplitude, which in this case is 3, and I need the period, which is 2 pi over the multiplier of x, which is pi. So that's again a period of 2. So I'll come out 1, 2, 3, 4, and put a 2, 1, 1, 2, 3, 4, and I'll put a -1 and a -2. Now guys, you could put the hash mark right here and say 3, and then it would look just like every other graph. Or if you want to make it look a little bit more like it traditionally would, I can extend this out to -3 and 3. This will just make it look taller, nothing else. But the important thing is that when you look at your graph, the peak is at 3. Whether that 3 is labeled right here or labeled up there, it doesn't matter. So I could put 3 right here, scribble that out, and use that as my 3, or scribble it out and put my 3 back up here. I'm going to, for the sake of different, really no other reason, I'm going to make these my 3's. Well, cosine function starts at its amplitude. It goes down to 0, then down to its minimum, up to 0, and then back up to the peak. If I wanted to continue this backwards so that I have a good pattern to follow, and then I can just start right here and work my way down. Oof, Mr. Welch, come on. Not the best at this when I'm not standing up at a board. Okay, but there's my general cosine function. When we grade this on Tuesday, the questions I'm going to ask are, did you start at 3? Now again, if you labeled 3 down here, you'd be starting down here. So just make sure you started at the right place, that you went down to -3 and then back up to 3. You did it over a distance of 2. And there's our cosine function. Last is our tangent. Tangent does not have an amplitude, but this 2 will be an important role in how I build my function later. First, let's start with my period, which is always pi over the multiplier of x, which is 4. So my period is pi fourths. So I got 1, 2, 3, 4, pi over 4, negative pi over 4. And then I want to find the vertical asymptotes, the places that would make the tangent for this equation undefined. And so I say that I have pi over 2 times the multiplier of x, which is 4, and that becomes pi over 8. Well, if this is pi fourths, halfway between 0 and pi fourths would be pi over 8. This would be negative pi over 8. So now I know that I'm going to have vertical asymptotes right here and right here. Those are lines I cannot touch, cannot cross. When I go to produce the tangent, I also know that it's centered at 0, 0. And that when I go over halfway to my asymptote, I should be at what we would typically consider the amplitude, which would be this 2. So when I come over 1, I should go up to 2. And when I go to the left, I should go down to negative 2 and put a dot. Now to produce the tangent curve, remember it's something generally like this. Again, my graphs on this board, for some reason I'm writing on, don't look real nice, but that's the graph. And that is what you need to be able to do periodically through the assignment. It will make the next assignment much easier, but you've got to get this much done first. Good luck.